Will quantum computers change the world in 2025? The dawn of quantum computing has been eagerly anticipated for decades, with promises of revolutionizing industries, unlocking new scientific discoveries, and reshaping the fabric of modern life. As 2025 looms on the horizon, many are asking the critical question: will quantum computers truly change the world by then? The simple answer is yes, though the extent of their impact may be more gradual and nuanced than many people realize. In this essay, we will explore the promise of quantum computing, the progress made toward its development, the challenges it still faces, and the industries that are most likely to feel its transformative effects. By understanding both the potential and the limitations of quantum technology, we can better anticipate the kind of world we will live in as quantum computers begin to make their mark in the mid-2020s. Imagine a world where we can simulate molecules to create breakthrough drugs at a fraction of the time and cost, or unlock the secrets of the universe by solving problems so complex that today's supercomputers can't even approach them. This is the promise of quantum computing, but is it all hype, or are we truly on the brink of a new technological era by 2025? The promise of quantum computing. More than just speed at its core, quantum computing is built on the principles of quantum mechanics, which govern the behavior of particles at the smallest scales of energy levels. Unlike classical computers, which use bits to process data as either 0 or 1, quantum computers use quantum bits, or qubits, that can exist simultaneously in multiple states thanks to phenomena like superposition and entanglement. This enables quantum computers to perform certain types of calculations exponentially faster than classical computers. The potential applications of quantum computing are staggering. For example, in cryptography, quantum computers could potentially crack encryption schemes that are currently deemed secure, leading to a complete overhaul of digital security systems. In material science and chemistry, quantum computers could simulate molecular interactions that would be impossible for classical computers, accelerating the discovery of new materials and drugs. Quantum computing also holds promise for optimization problems, artificial intelligence, climate modeling, and much more. The road to 2025, a period of rapid progress. Although quantum computing is still in its early stages, there has been significant progress over the past few years. Major technology companies like Google, IBM, and Microsoft, as well as startups and academic institutions, have made substantial investments in quantum research. Some companies have already developed quantum processors capable of performing rudimentary tasks, and others are exploring quantum algorithms that could one day solve complex problems in minutes rather than millennia. In 2019, Google famously announced that it had achieved quantum supremacy, meaning that its quantum computer had solved a problem that would have taken the most powerful classical supercomputer thousands of years to complete. While this milestone was more of a proof of concept rather than a practical application, it demonstrated the immense potential of quantum computing. Following Google, IBM, Honeywell, and other companies have continued to refine their quantum systems, with some promising to make quantum computing more accessible through cloud-based quantum services by 2025. However, while the progress is exciting, it's essential to acknowledge that quantum computers are still far from being fully functional, error-free, and scalable. Quantum systems remain highly fragile, requiring extremely cold temperatures and isolation from environmental noise to function. The complexity of quantum error correction is another major challenge. Quantum computers need to be able to correct errors in real time, a problem that has stymied researchers for years. The industries most likely to be transformed by quantum computing. Despite these challenges, certain industries are poised to benefit from quantum advancements sooner than others. These sectors will likely experience significant disruption and transformation by 2025, driven by both the early applications of quantum computing and the growing number of quantum computing services available in the cloud. 1. Pharmaceuticals and healthcare. Revolutionizing drug discovery. One of the most exciting prospects for quantum computing is in the field of drug discovery and healthcare. The traditional process of developing new drugs is time-consuming, expensive, and highly uncertain. It can take over a decade to bring a new drug to market, with billions of dollars in research and development costs. Much of this time is spent modeling complex molecular structures and simulating their behavior to understand how they might interact with the human body. Quantum computers are uniquely suited to solving these complex problems because of their ability to simulate molecular interactions at an unprecedented level of detail. Quantum simulations could allow scientists to model molecules and their behavior in ways that are impossible for classical computers to achieve. This could lead to faster, more accurate drug discovery, the design of personalized medicine, and even the creation of entirely new classes of drugs that target diseases at the molecular level. By 2025, we may see the first real-world applications of quantum computing in drug design, with quantum-powered simulations helping researchers identify promising drug candidates much more quickly than they can today. 2. Cryptography, a new era of security challenges. Quantum computing also promises to upend the world of cybersecurity. The cryptographic algorithms that underlie much of today's digital security, such as RSA encryption, rely on the difficulty of factoring large numbers, a task that is computationally infeasible for classical computers. However, quantum computers can theoretically break these algorithms using a method called Shor's algorithm, which can factor large numbers exponentially faster than classical algorithms. This raises significant concerns for industries that rely on secure communications, such as finance, government, and defense. By 2025, quantum computers may be powerful enough to break existing cryptographic standards, potentially leading to a paradigm shift in cybersecurity. Governments and corporations are already investing heavily in post-quantum cryptography, new encryption methods that are resistant to quantum attacks. On the other hand, quantum computing could also create entirely new ways to secure data using quantum key distribution, QKD, which leverages the principles of quantum mechanics to create unbreakable encryption. As quantum technologies evolve, the cybersecurity landscape will have to adapt rapidly to these new threats and opportunities. 3. Artificial intelligence and machine learning, accelerating AI development. Quantum computing could also have a profound impact on the development of artificial intelligence, AI. Classical computers are already pushing the boundaries of machine learning, but quantum computers have the potential to accelerate this progress by solving optimization problems much faster. Quantum algorithms could enable AI systems to process and analyze large datasets more efficiently, leading to breakthroughs in pattern recognition, decision-making, and predictive modeling. For example, in fields like natural language processing, quantum computing could enable AI systems to better understand context, nuance, and meaning, leading to more powerful and human-like AI models. Quantum-enhanced machine learning could also help solve problems related to climate change, resource allocation, and even drug discovery, by optimizing complex systems in ways that were previously unimaginable. By 2025, we could see early-stage quantum algorithms being applied to real-world AI problems, though it may take longer for these applications to become mainstream. 4. Optimization and logistics, streamlining complex systems. Another area where quantum computing is expected to make an immediate impact is optimization. Many industries, such as transportation, manufacturing, and finance, rely on optimization algorithms to improve efficiency, reduce costs, and enhance decision-making. However, many of these optimization problems are so complex that classical computers struggle to find the most efficient solutions. Quantum computers, on the other hand, excel at solving certain types of optimization problems, such as the traveling salesman problem, which seeks the most efficient route for visiting a set of locations. In the near future, quantum-powered optimization could help companies streamline supply chains, optimize energy usage, and improve financial portfolios. This could lead to significant cost savings and more sustainable business practices across a variety of sectors. 5. Climate modeling and environmental science, addressing global challenges. Quantum computing also holds promise in the realm of climate modeling and environmental science. The ability to simulate complex environmental systems, such as weather patterns, ocean currents, and ecosystem interactions, requires immense computational power. Classical supercomputers can model these systems, but their predictions are often limited by the accuracy and scale of the models. Quantum computers, with their ability to handle vast amounts of data and simulate complex interactions, could dramatically improve the accuracy of climate models. This could help scientists better understand climate change, predict extreme weather events, and develop more effective solutions for mitigating environmental damage. By 2025, quantum computing could become an essential tool in the fight against climate change. Challenges on the horizon. Quantum computing is not without its obstacles. Despite the excitement and promise, quantum computing faces several major hurdles that must be overcome before it can realize its full potential. These include 1. Scalability. Current quantum computers have only a small number of qubits, and adding more qubits to increase computational power is a major challenge. For quantum computers to be truly useful, they need to scale to thousands or even millions of qubits. 2. Error correction. Quantum systems are highly susceptible to errors due to environmental noise and the fragile nature of quantum states. Error correction is an active area of research, but it remains a significant roadblock to large-scale, practical quantum computers. 3. Cost and accessibility. Building and maintaining quantum computers requires highly specialized equipment, such as ultra-cold refrigerators and vacuum chambers, making them expensive and difficult to access. As quantum computing becomes more widespread, it's likely that cloud-based quantum services will make these resources more accessible to researchers and businesses alike. Conclusion: a future shaped by quantum computing? By 2025, quantum computers will not have fully changed the world, but their influence will be starting to ripple through key sectors of the economy and society. The drug discovery process could be revolutionized, AI might be supercharged, cybersecurity could be transformed, and complex optimization problems could find faster solutions. However, the full-scale, everyday application of quantum computing in many industries will likely take